Hello, I'm Alberto and I'm gonna present the electromechanical system project that is gonna be using transistors, jumping cables, the breadboard, the Arduino, and I'm gonna say what everything does, what's the purpose of this project, and the overall conclusion. Okay, so the Arduino is gonna get some current, it's gonna have the power, and then you're gonna use this one. You're gonna connect two wires. It's gonna be the positive and the negative. The positive is gonna go to the 5 volts that we're gonna put, and why 5 volts? Because this one gives us the option to put a 5 volts in here. So, and the negative is going to the ground. So this way, we don't need to worry about the current. Where do we connect it? On this case, we're gonna use our cable. So we're just gonna plug it in or on our laptop. That way I don't get rid of my battery. But if I will choose to use a battery, I will just take this one, and instead of connecting it, so is this one will be connected to in here. Instead of here, that we're gonna use the laptop, we're gonna put it here. So you have those options. So well, yeah, that's the Arduino. That's what this one will make. It's gonna make the current grow straight from 5 volts, whatever. For example, this one is 9 volts. So what Arduino is gonna make is just gonna send 5 volts in there, so you don't have a lot of current. We're gonna just jump in wires. So I'm gonna use a couple of them because we really need to use them, as we're using 2 transistors, 1 resistor, and all that. So I just have them here on hand. So we also have a LED that is gonna be our lights to know, so in this project we're gonna utilize this light, but however, you can send these instead of using this, using an AC, your heater, your speaker, your TV, something, everything, just to make your house a smart house that is gonna make more efficient your life. It's gonna save energy, it's gonna save a lot of things, money probably, and automation. There's a lot of warehouses, Amazon. I work in UPS, and we have probably like a robot, like automated hub, it gets rid of manual hand workers. That way it's more efficient, and it saves times and cost. In this case, we're gonna use also I resistor on this one, and I forget for the LED. Okay, the LED, you guys remember that it's gonna have a large one and a short one. For this one, we're gonna put the long one on the positive, and the short one on the negative. So the negative is gonna go to the ground. So we're gonna pop up and plug everything on our breadboard. Alright, so now we completed. In this case, I used the battery because I was recording on my laptop, so if I move it, it's gonna move the angle of the camera. So here we have the 9 volts, and then it's gonna go to the Arduinos that is gonna transfer it to a 5 volts, as it says here. 5 volts, that is the red one, and the blue one is gonna be the ground. So it's gonna be in the negative. We're gonna plug it in, red with red, blue with blue, that is negative. We're gonna go to jump on the resistor. So it's gonna jump in here, and then the current will be on this side. So the current will go to that transistor. Well, in this case, the yellow ones, they're gonna be just the circuit. In this case, I'm gonna have it here. So in this case, this one is gonna be the yellow one. All these is gonna be the yellow one. Okay, this one here, we have our LED, and it's gonna hold here. So all these ones is gonna be the yellow ones. So here we have the orange ones are gonna be our switches. In this case, this one will be our orange one. All right. So I'm gonna just unplug them. Let's say we turn off the switch. And as you can see, the LED is now off. Why? Because no current is passing through over there. So here we can appreciate our resistor is coming to here, but there's no connector transfer from here to the second one. So there's no current passing by. This one is gonna call the logic gate and what it's gonna do is that so here we have it. So if no current is going to A, we're not gonna have no current in AB. AB is gonna be our LED in this case. If we have current on A, but no current in A, but current on B is gonna be the same ones. So the AND, it means like we need both of them to have current, that way our LED is gonna have current. So now I'm gonna show you how the switch is gonna be. So we're gonna connect it from the resistor in here to second one. So we have current on A, no current on B. We're not having current on our LED. That's gonna be AB. So here we're gonna have current on A, current on B, current on AB. So this one is our AND logic gate. So this is how it works, because if we also disconnect, here we have it. We plug it. Oh, yep. So we can use this one for example, an AC. If you wanted, like when the AC detects the sensor motion, like you put a sensor that is gonna sense the movements and all that, and it recognizes that someone in a habitation, well, it's gonna have one thing, but it's missing another one. For example, the other one is mean like if you have a heater, your temperature is on 60 and you want it on 65. Well, the temperature now has a reason why to turn on, because the temperature is lower than you want to, and it's sensing something, so it's gonna turn on. But if it's just sensing motion but the temperature is good, it's not gonna turn on. So this one is a good example for an AC or a cooler on a heater on your house. All right. All right. So in this case, we have our logic gate, or it's gonna be this one or this one. So in this case, it's gonna be the same. The yellow ones are gonna be our regular cables, our connection, our resistor, our transistors, LED, and yellow ones. Okay, so we have power in here, the 9 volts converted to the 5 volts. For our Arduinos. So in this case, I'm gonna move it so we can appreciate it more from here. So we have our power coming in here. Okay, so here's 1 transistor, 2, 3, the 3 legs from that transistor. Then we can unplug our switch so we can take more look at our first connections. So our positive is gonna be connected to our positive, and the negative is gonna be connected to the negative. So that's our parallel circuit. So as we see here, it's gonna be one leg of our transistor, the other leg into that transistor. So both of them are gonna be connected to the positive side. It's gonna be this one. And there, our negative side is gonna be our third leg from the transistor connected to our negative. So this one will be mean that it's gonna be connected on parallel. So here, we're gonna have this with our second leg, that when we connect it in here, that is gonna be our orange line. It's gonna be connected to something like this. The LED will turn on, all right? Here we have, if we turn it on and on, our LED is gonna be on. If we have off and off, it's gonna be off. If we have on and off, it's gonna be on. If we have off and on, it's gonna be on. So that's our table that it looks like. pretty much the same, just different concepts, but it means the same. That this one is gonna be either or. You have one switch on, you're gonna have current passing through the LED. Or in this case, I'm gonna utilize the example of a phone. So if you have a phone that is gonna use a face recognition or a pin that you just put you put your password, and that's it. Well, you're gonna have a, let me see, because I'm not seeing pretty good. Okay, so it's not this one, it's gonna be this one. So we have our first switch on. Let me plug it in. But we don't have this one. That's why, because the current is passing through this one. Okay, so it's gonna go through here. It's gonna be connected from here, and it's gonna power our LED. Alright, so it's gonna be either or, because if I unplug this one and I plug it in here, I'm gonna have light. And what would happen if we just plug it in the other one too? It's gonna still have our LED on. Okay, so going back to the example that I was utilizing, if you have a phone, let's see, this is our phone. So if it recognizes my fingerprint, it's gonna unlock. Okay, so boom, oh, it's gonna unlock. But if I turn it on and I just put my password, boom, boom, it's gonna turn on. Okay, so he's not gonna need the password and your fingerprint to unlock. He's gonna utilize one. So this is an example for using or a logic gate. Alright guys, so here we have our NOT gates. So what it's gonna mean is gonna have like either or, is gonna act as a switch. So in this case, for example, if it'll be on, right? So if we have daylight, our transistor is gonna turn on technically, and it's gonna turn off the light. All right. Other things, for example, if you have the alarm of your house, the security alarm on your house, it's gonna be on, right? Then supposedly you put the password, right? So it's gonna turn on. It's gonna turn off the security alarm. So you're not gonna worry about moving, opening doors, and the alarm coming on. So if you turn it off, technically, if you turn on the security, because you're going out, it's gonna disconnect it. So now the security is gonna have energy and it's gonna be working. So if you open a door, open a window, or sensor motion is sensing to the house, it's gonna turn the alarm. So if you go back to your house and you plug in the password and it's right, it's gonna turn off. All right, so this is another example. So how it works, so in this case, we're gonna have the positive is gonna go into here, and then we're gonna connect it directly to the LED. So it's gonna have this gate, it's gonna either go this way, or either it's going to go this way to that transistor, pass through, be connected to the negative, and it's gonna be here. This is when we have a transistor on, because we have our connections. But if we turn it off, of course, the energy is gonna pass through this one, because it's gonna be easier for it. Okay, so it's gonna jump, and no worries about this one. But if you connect it, it's gonna choose this loop, and it's gonna go in here, like this. All right. So now we have all these hands-on is much easier. I learned a lot. I know that transistors can be used a lot in automation, smart houses, cars, and the wipers, and sensing rain, and it's gonna turn on, turn off if it senses rain, if it sense rain, but your car is not turned on, well, they're not gonna turn on, you know. So you're gonna have like different ideas, different concepts that you can use them in your daily lives. Cell phones, computers, they all have a lot of transistors, lights, you know. So automation is gonna be the key of, or keep improving quality of life, improving all that. And thank you guys, thank you. I hope you all learned something. See you.